And beautiful, everything is working. So my name is Boris Lubinsky. I work as a principal architect in Lightband. And by the collection of the books, you see how my interests have been progressing from SOA to Hadoop to model serving, and the final book that Michael was kind enough to talk about is Kubeflow for machine learning.
Hello, everyone. Good afternoon and good night for me. It's almost like not 1 a.m. but 12 a.m. In my local time. So my name is Oleh, Oleh Dokuka. I'm just normal software engineer who is big fan of reactive programming and reactive streams. And it happened that at some point in time, I started working on RSocket project Reactor, and now I'm leading RSocket project, uh, about which we're going to be talking today, basically. I wrote not that much book, but if you're curious, I have a book about reactive programming in Spring. But yeah, this is another talk. So, Boris, what are we going to talk today?
So we'll start talking about Cloudflow. So we will start by discussing what is Cloudflow and why. And we will look at the lessons from the past. I shamelessly stole this slide from my former boss, Dean Wampler. But what typically was happening and is happening very often right now is when people are trying to build the complex streaming system, they focus more on plumbing than on business logic. And very quickly, the system is growing large, so it becomes difficult to manage and provision. It has ad hoc infrastructure, and it has tons of boilerplate code, which people cut and paste from one application to another. So what we were trying to look at in Lightband, and now it is an open source project, Cloudflow is built around the notion of streamlet. For those of you who are fan of the microservices, Streamlit is quite akin to the microservice, and streamlets are connected to Kafka. The other through Kafka. The other problem that we were trying to solve is people usually pick their streaming framework or streaming server, and they build everything using a single approach. What Cloudflow allows you kind of is to mix and match implementation that are written Akka streams. Keep in mind, I work for Lightband, so Akka streams is the best thing ever. But we also support Flink, and we also support Spark streaming. The idea of a streamlet is quite simple. Streamlet is defined by the shape, which is the inputs and outputs. But here we're going one step further, and we define the inputs and outputs by data schemas that they fulfill. So we are introducing a strongly typed contracts onto streaming. And the second important thing in Cloudflow is a blueprint, which basically describes how streamlets are connected to different Kafka topics. And the streamlet can read from the Kafka topic, it can write to the Kafka topic. Multiple streamlets can write to the same topic, and multiple streamlets can read from the same topic. So as a foundation of the Cloudflow, there are three main components. There are APIs that are both for Scala and Java, except for Spark, because using Spark from Java is very unnatural. And at the moment, we only support JVM-based language. We also have Kubernetes operator, and we have Kubernetes. We have configuration support. So what our APIs allow you to do is to write less boilerplate code. At the end of the presentation, I will show you the actual code. They support multiple streaming engines and libraries, including Akka Streams, Flink, and Spark Stream. And I can show you the code, for example, for Akka Streams and Flink. They're kind of different, but they are built based on the same philosophy. They allow you to use the right streaming tool. They allow you to worry less about plumbing. You should still worry about plumbing, but the majority of plumbing is generated for you, and they allow you to reuse microservices best practices. So the Kubernetes is managing the whole thing, and it provides convenient allows you to deploy applications. It allows you to list existing application. It allows you, of course, to and it allows you to scale the application. Configuration is another centerpiece of Cloudflow because we're moving more and more from hard coding things in the code and moving them to the Hohon files. And those are quite elaborate configurations that you can do. Again, I will show you some of the examples at the end of the presentation. So with all this, how do you create Cloudflow applications? You start from defined schema, as in all respected programming languages. It's schema first, it's API first, and based on these APIs, you implement the business logic. And then you write the blueprint, which defines how streams are connected to each other. Once these three pieces are in place, you can build Docker images, deployment artifacts, and you can also use additional configuration. For example, which database name to use, things like that. All this is going to the Kubernetes cluster. Cloudflow absolutely requires Kubernetes. That's the only platform that it runs on. And it provides some monitoring based on Prometheus. This is a very quick and rough architecture diagram that talks about the main components and the interactions inside the Kubernetes cluster. You installed Cloudflow, which basically installs the operator, and the operator now can install the new Cloudflow pipelines and manage them. And the approach that we have chosen is Cloudflow operator is a composite operator that interacts with Flink and Spark operators to manage the actual Flink and Spark jobs.
That looks awesome. I mean, in general, what I understood, I mean, I'm not that familiar with Cloudflow, of course, but what I understood from your speech is that basically Cloudflow let you abstract from the environment. It let you focus on data processing, which is integrated with awesome things like Kafka, which is integrated with Flink and big data processing tooling, and let you just build your data processing pipeline, which is cool. So having that, we can imagine that we have like a streaming app. But now the question, how I can send data to this app? For example, it's clear I can use file, but what about browsers, mobile phone, or IoT? Do you have any transports that supports that, like Ingress data flow?
Thank you, Oleg. As usual, very good question. So Cloudflow supports Ingress transport, and currently Cloudflow provides two main external ingresses. So if you run inside the Kubernetes cluster, you can communicate with Cloudflow applications via HTTP and gRPC. Is it sufficient? Not always. HTTP is kind of slow. gRPC might require special provisions on the Kubernetes ingresses. For example, Nginx does support gRPC, but you have to muck around a little bit to make it work. It has its own challenges on integrating different messaging formats, and it has limited support for other transports like WebSocket, Aaron, others. And that's why we started talking with Oleh, who is RSocket guru. And now we lost our presentation. Not for long. Go, you control. So that's why we started talking with Oleg about RSockets. You control.
Yeah. So having that and looking into that, what I understand is that there is some challenges related to data sending into Cloudflow. And there is some challenges related to HTTP, it's slow. If it's HTTP2, it's another challenges, which is technical challenges. And of course, there is no WebSocket Aaron if we need some great performance, which is not great. But you know, I have a solution for you. And solution is called, sorry, another technical issue. And solution is called RSocket. So you may wonder what RSocket is. Basically, think about RSocket as about network protocol, similar to TCP, UDP, but a little bit higher for application and business needs. RSocket is not it's not just another protocol built for fun. Now, RSocket build is by leaders of software engineering, microservices, and cloud computing, and they knew what they need. So first thing that related to RSocket is that RSocket implements reactive streams semantic. What does it mean? It means that now you can easily control your application messaging flow, which is related to resilience. And I will be talking about that a little bit later. A part of that, it let you do everything that you've done before with the same HTTP. You can do RPC if it's necessary, or you can build any event-driven or event-based messaging if you want. And RSocket is about performance. It's 10 times faster than HTTP. It can be faster than HTTP2 and TCP by using some cool stuff related to RSocket. And that's great because now you can close all the problems that you have. You can close performance issue, you can close resilience issue, and I will show you a little bit more how you can do that. So some boring stuff. RSocket is based on message-driven concept. So what does it mean for you? Basically, it means that now you can focus on your message passing. It doesn't matter what message format. RSocket is binary messaging protocol. It delivers your binary message over the network as fast as possible. Of course, depends on your data size, and then give you the same data as you send from the requester. So binary messaging is pretty opaque. You have your logical message. This logical message is split onto data and metadata, as normal protocol does, like HTTP, for example. And everything related to your logical message is binary, which means that now it supports any message format. If you want to send JSON, go ahead and do it. If you want to send protobuf, you can do that as well. Metadata basically enables common headers and meta info in order to exchange, for example, routing. And of course, RSocket brings some standardized things like tracing, monitoring, etc., which is basically commonly used in cloud infrastructure. So you have predefined layout for that, and you can just use it on both sides. So that's not only about RSocket. RSocket following the best practice, and RSocket not only designed for normal exchange of messages. So it supports multiple communication styles, which opens it for many use cases. For example, you can use it in the same way as HTTP communication, so you can do request response. Or for example, if you need live streaming of your data from server to client, there is request stream. Moreover, if you need bidirectional streaming, we support that. And just in case you have to drop your message and forget about it, for example, like logs, we can do that efficiently for you. So that's cool part. But you may wonder, okay, if we support multiple communication styles, how that mapped onto your connection? Is it performant enough? That's an important question related to performance. Well, RSocket following the best practices from protocols design, for example, from HTTP2, and it supports the same multiplexing as HTTP2 does. So you may send all your messages, and they will be sent to the same session, to the same connection, which is cool. RSocket defines everything about logical definition and distinction between your messages, so you can focus only on message passing. But that's not the main feature. This is pretty standard part of today's protocol. The main feature about RSocket is related to transport pluggability. So what does it mean? It means that basically RSocket defines notions related to message framing, multiplexing, your logical streams, stream ID, etc., etc. But that's not what you have to use, and that's not what you have to work with. RSocket lets you focus on your business logic, on what you do with your messages and how you send them. So you can do your request response, you can do your request stream or bidirectional streaming, and that's all your logical communication channels. Then everything that you do is sent to RSocket level, and RSocket decode your logical message into appropriate framing, binary framing. But now the question, okay, how to send this frame from one client, for example, to a server, from requester to responder? Well, there is proper transport abstraction, and you can plug any reliable binary transport in order to wire communication between your points. So using that transport abstraction, you just send your binary data, your byte buffer, and responder receive it and transform into your logical message. So you focus on your business logic only. Moreover, now having that abstraction, you can easily plug in any transport you want. For example, you can use TCP in your for example, local tests, or you can use your local transport if you need. But then if it's necessary, you can easily change your transport on another. For example, if you have clients communicating to your cloud and cloud provider does not allow through the firewall some TCP connections, go ahead and change your transport onto WebSocket, or open multiple ports, which is possible as well. And the main feature is that you don't have to change your business logic. It's properly abstracted from the transport, which is awesome. Now, if you need more performance, go ahead for UDP and use UDP-based transport like Aaron or Quick. We all support them, which is great. But that's not only it. If you need something custom, for example, you care about every piece of your time that message goes through the network, and you want to squeeze the best latency and the best throughput, go ahead and build your shared memory transport. The API of transport is pretty straightforward. Or for example, if you want to have some fun with Kafka or any message broker, you can do that as well, which is cool. I like it. But that's not only about RSocket. That's a great part about RSocket. But RSocket brings even more. RSocket brings reliability. So if you remember, I say that RSocket implements reactive streams. So you may wonder what reactive streams, but of course you know what is it because we are at Reactive Summit. So just to remind you, reactive streams is a specification which is focused on streaming and let you and define some communication patterns between your data source and your data subscriber. So it defines publisher and subscriber, and there is a contract, which is straightforward contract. Subscriber says subscribe to publisher, and publisher gives you subscription, and now subscriber can request some data, and that's how we have flow control, application flow control reliability, because publisher will produce exactly stream of 5 elements, and if you want more, you can request again. So having that, RSocket fully implement the same semantic, but as a network protocol for your, for example, data streaming. Then it propagates all the signals that defined in reactive stream specification as message frames. So what does it mean? For example, you call request and you want to get some data from your publisher on the other end of the network. So this request method invocation is transformed onto frame, sent to your recipient transform it back. So this is done inside RSocket, and then propagate it as the same request. So now you have full transparency in your reactive streams, but over the network, which is good. And then responder or publisher produce your information over on next, and that's delivered to your recipient, to your subscriber. And that's fair. But that's not only about reactive streams. RSocket brings something even more advanced. So RSocket defines built-in request limiting, and that's request limiting not only on the client side, and not client side is guessing whether it can send data or not. Responder dictate to all the connected clients whether they are allowed to send requests or not. And that's pretty reliable, believe me. And having that, you can easily build pretty smart circuit breaker logic, or you can define really advanced load balancing, because now you know in advance whether you are allowed to send data, how many requests you're allowed to do, etc., etc. And based on that, you can define your pretty smart algorithm. So in addition, RSocket is peer-to-peer communication protocol, which means that in general, client is needed to establish connection. But once that happens, both sides are equal. They can define request handling logic, and they can act as a client as well as a server, both sides. So what it means, imagine that your browser becomes a server, or your mobile phone can respond to some request from your server, which is great. So having that, let's sum up something about RSocket. In general, RSocket seems pretty standard network protocol, which embraces common things from HTTP2, from other popular communication protocols, for example, like SignalR or ZeroMQ, but that's not the main feature of RSocket. That's pretty standard part. The main idea of RSocket is related to reactive streams and pretty good flow control. It related to resilience. Resilience in RSocket is a first-class citizen. That's why we build in rate limiting and leasing. And then if you want to have even more, we support resumability. So now you can make sure that your messages from your mobile phone are delivered. And for example, if your mobile phone in the idle state, you can easily unblock it and reestablish connection and continue easily without any helps your previous streaming. That's built in. Then if you want to send big data, that's supported with fragmented for you. And if you want to extend the protocol, it's also possible. On top of that, you may send any data format. You may use any communication style. If you want, we have RSocket RPC, which is identical to gRPC. You can use something related to messaging like Sprint messaging. And of course, you can use RSocket in any language that we support, and we support many of them. Finally, you can use any transport. You don't have to choose your business logic. You just focus on how you communicate. And if it's needed, you can choose your transport and switch it. So from my standpoint, let's say that having RSocket in Cloudflow, we can solve a lot of problems. So for example, come into our solution, come into our problem. We have stream processing app. And previously we had some challenges related to data sending. But now if we implement, for example, communication over RSocket, in theory we can support it in multiple languages, the same protocol, similar to HTTP, in different devices. And now you have reliability, and you can not easily kill your cloud stream processing application. So having that, let's take a look at some code. Boris, can you show us some bits of RSocket and Cloudflow, please?
Of course, the moment you gave me control.
Yeah, go ahead and do that.
Okay, so let's start from the very simple thing. I took a simple Cloudflow application, deploy it on GKE, and yeah, the screen is, the UI is not ideal, but is better than anything. You can see that Cloudflow application is a graph, and the first element of the graph is receiving RSocket messages, and you can see that I'm receiving about 20 records per second, and I'm submitting them back to processing. How do I do that? I have on my box running the simple application that is sending RSockets to my server. And this was one of the things that Oleh was talking about that is absolutely great in RSockets. So my initial implementation was using TCP client transport. And of course, Google Cloud Ingress won't let it through. And literally, that's the only thing that I had to change to make it work with the cluster. So now I can communicate from my laptop to the Cloudflow application running on Google Cloud. And if I can do it from my laptop, I'm sure I can do it from anything in the world, because my laptop is not the best thing ever. So let's look at some implementation details. First, I've been talking about blueprint, and this is the example of the blueprint that we're using. The blueprint has two parts. It has the definition of the streamlets, which has the list of all the streamlets, and it has the definition of all the Kafka topics used by application. And for every topic, I'm specifying who consumers are and who producers are for a given topic. And finally, if just an example of how simple is the code for those of you who know Stream, you would recognize this code. It's basically the logic of the application written in the Streams with all the boilerplate being connectivity and everything else implemented by Cloudflow. As a comparison, I can show you similar implementation in Fling, and you will see that it's very, very similar. It works this way. This, I think, Mike, we are out of time, but let's see if we can get at least one question. And of course, we'll be happy to answer more.
We do have some questions around the support on the user browser. There's some concern that maybe the RSocket JS project isn't being actively maintained. What's the status on that? I think this is more for Oleh.
Yeah, thank you for question, whoever it is. But yeah, indeed, RSocket.js was not alive for a while, but now once we are good with stability of RSocket Java, and we spend a lot of effort to make RSocket Java really high performant, really stable, and really pleasant from the user API perspective. So now once we stabilize that, uh, we will be focusing on RSocket.js, and believe me, in a short period of time, you will get pretty great RSocket.js with support of with like properly written in TypeScript, because this is one of the most popular JS-based languages. So don't worry, you will get it soon, and it's going to be getting better and better. So that's what I can say as one who is involved in RSocket pretty intensively.